Okay, so yesterday's Basics Concepts Part 2 was dealing with domain and range, but we were looking at domain and range on a graphical representation. Today what we're going to look at is domain and range from a functional standpoint. So given the function, as you can see what we're looking at here, given the function coming up with the domain and range. So part of that is actually going back to the graph, and I'm going to be referencing those a little bit and how you know what happens to the graph for certain changes and transformations. But there are definitely different ways to look at that and to avoid maybe that graphical representation, but that's what makes most sense to me and what I reference back to make, see how that works. For each of these, we're going to come up with a set of rules, a set of kind of standbys for our domain, and a set of standbys for our parent functions for our range. So the first problem that we have in domain in any case is that the denominator can't be equal to 0. Say be equal to 0. The denominator can't be equal to 0. That's definitely a problem, right? We can't have 1 over 0 in our problem. We can't divide by 0. We get something that's undefined. It means it have a domain error. The value that we're putting in, the x value, can't be 0. The other problem that we have is that we cannot take the square root of a negative number. So that's the only other problem that we're going to deal with domain. Okay, so again, that means like the x values that we're putting in place, we have to limit them. We can't have all x values that are included. We're restricting it to these certain values that will work. Okay, that's when your calculator gives an undefined answer, right? It gives an error message. It'll happen at these places. Now, range again is what you're getting back out. So as I'm putting things into my function, what types of values am I getting back out? So the first one that I'm going to look at is the square root of x. Now, thinking about the square root of x, as I'm putting things into that, as I'm putting x values into that function, what kind of values am I getting back out? Am I getting back all values? Am I getting back negative numbers? Am I getting back decimals? And can I get back fractions? All that stuff. So the answer to that is pretty much yes. We can get out basically everything, but the square root of something is always going to be something that's positive. So we are only getting out positive values. So in fact, I'm going to draw the graph of what this looks like. Our range looks like that. Okay, so we can't take the square root of negative, so we're only inserting values that are bigger than 0. Okay, and then we're only getting values that are positive back out. So our range then, what we're looking at in interval notation, we can start at 0 and then this goes up to infinity. So that would be our range of our parent function that we have of square root of x. Again, we have different transformations that will happen, so it's not always just 0 to infinity, but that's at least a good starting point. And then we can kind of see what manipulations unfold to help us get to a different range. The other one we're going to look at is x squared. And again, we're deciding what kind of function or what kind of values can I put in, what kind of values am I taking out or getting back out. So as I'm putting x values in, the values that I'm receiving, the values that are getting spit back out of me are a particular set of values. Can I get decimals? Sure can. Can I get 0? Yes. Can I get negative values? No. Every time I square something, it's going to be positive. So again, I'm going to draw the graph over here. This is what this parent function looks like. And parent just means the most basic form that it can be. So that's what my parent function looks like. We learned yesterday about coming up with the range as we look at a graph. This dips down. The lowest value that it dips down to is 0, which makes sense. And we go up to infinity in both directions. So our range is again 0 to infinity. However, there's a lot of manipulation that can happen with any of these functions. One of the manipulations that we could have, and this is again a more common manipulation, is if we have negative x squared. Now if you're thinking back to algebra 2, this does something specific to the graph. It actually flips it over the x-axis. So now we're dealing with, instead of some parabola that's opening up, we're dealing with a parabola that opens down. Another way to think about that is as I'm putting values into my function and squaring them, so if I take positive 1, and I insert it into this function, and I square it, I get positive 1, and this negative will make it all negative. So all the values that I'm getting back out, although they're being squared, these will always be positive, but there's always a negative sign in front of that, which will make them always negative. So my range for this one, instead of going from 0 to infinity, I'm starting for my lowest values at negative infinity, and I'm going up to 0, and that's my highest value I can be. And again, these are all manipulations, or we're going to manipulate them all down here to find their domain and range. So these first two, we're just going to look at just finding the domain, and that's it. And again, if we're looking for the domain, we have one of these two issues maybe taking place. If we don't have one of those two issues, if we don't have a denominator that could be 0, and if we don't have a square root in our problem, then our answer is going to be all real numbers. Anything that we plug in, we can get a value back out. So that would, our answer would be negative infinity to infinity. But it's not always the case. So for this domain, we're looking for a problem area. So we definitely have a problem area. We have one of the two things. We don't have square root, but we do have a denominator. So this stuff can't equal 0. So what we're going to do is we're going to find out where it does equal 0. We're going to set the denominator equal to 0. So x minus 5 equals 0. This happens at 5. So if I plug in 5 to that equation, I'll have 3 over 5 minus 5. So 3 over 0, and my calculator will spit out an error at me. So when I come up with my domain, every other value except for that one will work. So any value from negative infinity to that number 5, but not including that number, so excluding it, and then any number bigger than 5. So I'd use my union and 5 to infinity. So what this means, again, is if I went negative infinity to infinity, I would be including every single real number that you could possibly think of. This, with this open parentheses, or the parentheses around the 5, means that I can go all the way up to 5, but not 5, and then anything above 5, but again, not 5. So I'm literally taking the entire number system and plucking 5 out of it. That's what I want you to think of as you're looking at your divide by 0 errors. Same thing for this one. We're going to find out where this linear equation equals 0. So I'm going to solve it. Subtract 6 from both sides. Divide by 5. And I get negative 6 over 5. So again, every single number will work except for that one. So in order to do every single number except for that one, we're taking our entire system of negative infinity to infinity, and we are plucking that one value out. So we want all numbers lower than negative 6 over 5, and we want all values higher than negative 6 over 5, but we want to make sure that we are not including 5, so we are excluding it. Okay, we're going to find the domain and range for both these. So looking at example 3, we're looking at the square root of x. So we're thinking, what values can I actually plug into this? So this is one of our issues. We can't take the square root of a negative number. So what this means is that anything under the square root, all this stuff has to be greater than or equal to 0. That's what we're going to look at. So this stuff underneath the square root, which is x has to be greater than or equal to 0. Now yesterday on that video you saw things that look like this. This is really set notation, right? We're looking at that, and we transformed that from interval notation to set notation to the graphical representation. We went back and forth between all that stuff. So we should be pretty familiar to figure out what that would be in an interval notation. X is greater than or equal to 0 means we're including it. We want values that are bigger. So anything bigger than 0. So including 0 and then bigger than it all the way to infinity. So that's what our domain would be. Our range is actually one of our rules, our first rule here of the square root of x. As I'm plugging in these positive values, I'm only getting positive values back out. If I plug in 0, I get 0. So 0 is the lowest possible value I could get for my range, and it goes on and on up to infinity. Okay, same idea. Slightly different. We've got some more stuff to worry about, but we have generally the same principle. That stuff is underneath the square root. That's really the problem that we have. We can't take the square root of a negative number. So this function, this expression, the 3x plus 4, has to be bigger than or equal to 0. I can't plug in negative 10 here. It won't work. You'll get an error. So we have to figure out where that cutoff is. So if I solve this, divide by 3, I again get that x has to be bigger than or equal to negative 4. So that defines my domain. I'm including negative 4 over 3. Sorry, I think I said negative 4 there. I'm at negative 4 over 3, negative 4/3. And I'm going up and up and up, and any value higher than that to infinity. There's no restriction on anything above that. Now, since this is my lowest possible value for my domain, if I actually plug that in, I'll end up getting 0. So again, this range, although it looks different than this one, nothing was really changing. We didn't do anything outside of the square root. We just manipulated the stuff inside the square root, which affects our domain. But nothing that we did outside of we didn't do anything outside of the square root, so nothing will actually be affected in our range this time. So we're still 0 to infinity. And you can double check by like plugging in a value of your domain and seeing where that happens. You'll see that the smallest value that you'll get is 0. Okay, same idea. We have one of the two problems here. We don't have a denominator, or we don't have a denominator, so it's not that one, but we do have a square root. So again, we're going to deal with that the same way. The stuff underneath the square root, we're going to set greater than or equal to 0 because we want that only to be positive, non-negative. I'm going to solve that. This tells us right away our domain. We want values that are bigger than or equal to negative 7/5. So we are including negative 7/5 and we are going off to infinity. Our range, though, is actually slightly different because this stuff is still the same. So if I plug in my lowest value into my function, I'll get, let's see, 5 times negative 7/5. The 5s will cancel. I'll have negative 7 plus 7. That will be 0. Square root of 0 is 0, and then I add 2 to it. So this 2 on the outside here, what this does is it shifts the graph up 2 units. Or it shifts your range up 2 units, in other words. Now this was not 0 anymore. We're adding 2 to it. So everything that we get for our original range, which was 0 to infinity, now we're adding 2 to it. So we can't get any, since this can't be negative, this is the smallest value it could possibly be for our range. So I'm going to shift this up for a second, as you can kind of see what this is looking like. If this is my original graph, it's called vertical shift when I add stuff at the end. Now I'll start here and I'll go off to infinity that way. So our range is affected. Instead, we're starting at 2 this time and going off to infinity. This definitely, by the way, is the hardest day of our basic concepts. It's not something that's super intuitive. It's something that you covered a little bit in Algebra 2, but it's been a while, especially with these transformations. So it can be sometimes hard to get a grasp on this, which is why there's an extra practice sheet that's posted on the website. So if you do finish today and finish the notes and you're still a little bit iffy, and tomorrow when we look at all of the practice that we have and you're still iffy about it, then you probably should look at the extra practice and the answers there and get a better grasp of what's happening. Okay? That's all, at least, that we're going to do for the square root functions, and we're going to shift to our parabolas. So we're going to analyze the domain and range for each of these. So let's start thinking about what values can I plug into this function. Well, what kind of issues do I have? Do I have a denominator? Nope. Do I have a square root? Nope. So our domain, since I don't have any problems, I don't have any rules that I'm breaking, our domain is going to be negative infinity to infinity. In other words, is there any number out there that I can't square? No, I can square any number. It might not be the prettiest number to square, right? But I can still take 0.1789 and square it and still get that in my calculator. So any number I could possibly think of, negative, positive, 0, I can square. Our range, though, this is one of our rules. When I square something, I always get something that's positive no matter what. So my range is 0 to infinity. Okay, same idea. Is there any problems with this? Do I have a denominator? No. Do I have a square root? No. Is there anything that I could plug into this function and not get a value back out? Nope, I can plug in anything. All I'm doing again is squaring it and subtracting 3, and I'll get any value I can possibly imagine. Our range, though, again, is affected. It's kind of like this one up here, example 5, where we can get this value. Our original range was 0 to infinity, but then we subtract 3 to it. So what that does is it takes our original graph, which looked like this, and it is a vertical shift down. So instead of being at 0, 0, our first point that we plot, our vertex point, is at 0, -3. So our range for this one is -3 into infinity. So this shifts down 3. And again, I like to do this with our transformations because I think that it makes the most sense. But you can always try to plug in some numbers and see if you can come up with a range that way. But if you think through it, what numbers am I actually getting out, and starting with 0 and 1 and -1, that kind of helps frame where you are with your range. All right, same question we're asking. As I'm looking at y equals 5x squared, is there any problems that I'm dealing with? Do I have a square root? Do I have a denominator? The answer is no. I can plug in any value. I can square any value. Same thing that we've been saying. Our range, though, the thing that's different about example 6 and example 8, well, what we're doing is we're taking that x squared and we're multiplying it by 5. So is that really changing our graph as far as our range is concerned? Not really. So I can still plug in, say, 1. If I plug in 1, I get 1 squared times 5 is 5. Plug in -1, I still get +5. If I plug in 0, I'll get 0 still. So there's no way that we're going below 0 in this case. So our range is still 0 to infinity. All that 5 does is it makes it grow faster. So instead of having a parabola that looks like this, we have a parabola that's skinnier. But it doesn't shift it down or up anywhere. It still starts at 0, 0 in both of these things. Last couple, again, our domain is for any of these square root ones, or sorry, any of these quadratics that we're looking at, they're always -infinity to infinity because we don't have those problems. We don't have a negative, or we don't have a negative under the square root. We don't have a denominator. This range one is a little bit tricky. We've got a couple different things that are affecting it. One, we have this 3, which we talked about over here. This doesn't actually change it. As long as it's positive, there's no problem. So this 3 doesn't matter. We have this 5, which from here, this shifts it up 5 units. So that's going to take our range and shift it up 5. This x minus 4 is kind of like example 3, where we're manipulating things within the function. So what this actually does is it shifts it to the right 4 units, but shifting it to the right and left doesn't affect our range. That would affect our domain. However, we're already -infinity to infinity, so we don't have to worry about shifting where our starting point for our domain is because it's included in all numbers anyway. Shifting it over 4 units is still going to expand everything. But our range is affected, so for this one, we're going from 5 to infinity. So when we worry about your range, you really only have to worry about these numbers here on the outside. So you have to look at this one and see if it's positive or negative, and then you have to look at this outside number and to decide if it's also positive or negative, and that will shift your starting point. Okay, a couple more that we're going to deal with. Still, we're going to look at these quadratic functions, but they're slightly different because these ones that we're all looking at are all negative. And in the front, I'm just going to redraw it so we can look at it. here, and I don't have to keep flipping back and forth. That's what our negative x squared graph looks, and our range for this parent function is negative infinity to 0. So instead we're flipping the graph all the way over, so our range flips all the way over 2. Again, if we're looking at our domains, do we have any problems with domains? Do we have a denominator? Do we have a square root? Nope. So we're at negative infinity to infinity. Our range, again, this is our parent function. So all the values that we plug in are going to be positive, and then we have this negative on the outside, so it makes it negative, which flips our range completely over, completely around. Instead of going from 0 to infinity, we're going from negative infinity to 0. Okay, our range is still negative infinity to infinity. Again, we have to look at a couple things. One, we have this negative, which means we're going to go from negative infinity to some point. Like that tells us that we are flipping our range. And then we have this plus 6 on the outside. And that plus 6 has a vertical shift up 6 units. So we're taking this graph and we're moving it up 6 units. So we're still going off to negative infinity, but our new point for our range, our new like kind of maximum point is 6. So instead of stopping at 0, we're stopping at 6. Last couple, again, this is a quadratic graph. Our range is, or domain is still negative infinity to infinity. We don't have any problem areas. Our range, we have got a couple things. We've got a negative 3. The fact that it's a 3 doesn't matter, but this negative does matter. That again tells us that we're starting at negative infinity and we're going to some value. And that some value is affected by this vertical shift, this vertical transformation, which is plus 2. So that shifts the graph up 2 units. So just like example 11, we're stopping at this case at 2 rather than 6, or in rather than 0. Okay, last one. Analyzing this. Again, when we do this more, they'll be all mixed up. So you do need to know the rules and what to look for. So I always think, again, when I'm looking at that, do I have any divide by 0 errors that could happen? And do I have any square roots? And neither of those are true. Or you can really think of, is there any value that I could plug into this that will give me an error? Is there anything that I can't plug in? And in this case, no. You can plug in any x value that you want. Our range, we have to look at a couple different things. So we're thinking, okay, it's a quadratic. So probably 0 was involved for the original parent function. So yeah. So we have to decide what that graph looks like. Are we starting at negative infinity and going to that point? Or are we starting at that point, whatever that may be, and going off to infinity? So this negative tells us again that we are flipping it over, so it's pointing down this time. So we're going negative infinity to some particular point, and we've got two like choices to choose from. This plus 2 here, and then this minus 5. This is actually again inside. It's with the x, so since it's with the x, it affects the x, and x is our domain. So we don't have to worry about this plus 2. It's not going to have any impact on our range. This minus 5 will, though. This minus 5 is affecting our y value, and that shifts the graph down 5 units, so we are stopping at this case at negative 5. Okay, last little part for today is talking about linear equations, all linear functions that we look at. All lines have domains of negative infinity to infinity, and they all have ranges of also negative infinity to infinity, except for vertical and horizontal lines. So I'm going to draw you a picture real quick of any line. It should make sense that this thing has a range and a domain of negative infinity to infinity. There are no holes in my line. I'm stretching from all the way to the left with an arrow pointing this way, down and to the left, and I'm stretching all the way to the right with an arrow pointing up and to the right. That means that my domain is all negative infinity to infinity, all real numbers. Same thing for our range. I'm going down forever, I'm going up forever, so my range should be negative infinity to infinity. These problems, every time that we're looking at something that has a linear equation, these problems are really, really easy. but it's really easy to mess them up. You might be tempted to be like, okay, this plus 2, we've just been looking at this whole time. This plus 2, that means that it's affecting our range. We're shifting it up 2 units and we're stopping at 2. You might be tempted for that, but you have to look too at what kind of function it actually is. The only ones that we're dealing with that affect the range are square root graphs that has something to do with the range, and something squared. Okay, those are the only 2 functions that we're really looking at that affect the range. So since that has neither, it's kind of like the domain question of, do I have a denominator and am I dividing by, or am I taking the square root of a negative number? You have to ask those same questions on your range. Do I have a x squared and do I have a square root? And if the answer is yes, then you do have domain problems. But if the answer is no, which in this case, since all my powers are just 1 anyway, I know I'm not squaring anything, the answer is no. So my range is negative infinity to infinity. If I graph this, it'd just be a line. In fact, you should know how to graph it, right? You start with y-intercept at 2. You go up 3 over 1. That's your slope. Draw your line. It would extend in all directions. Same thing here, although it looks a little bit different. This is something in standard form, but it's still a linear equation because I don't have a power, a higher power than 1 on for my exponents of my x and my y value. So my domain, no problems. Negative infinity to infinity, I can plug in any value I want. My range, I can also get out any value I want. So those, again, are the main concepts here. We have to look at these kind of rules for domain, and then rules for range. Do I have a square root? Do I have an x squared? Is there a negative involved? And for the domain, do I have a denominator? Do I have a square root? You're kind of asking yourself those questions as you're looking at that. And again, I think this is the hardest day, is this basic concepts for these functions. So again, if this was a little bit challenging, if you're really not quite sure yet, and you still go through your practice tomorrow in class and you're still a little bit iffy on it, then it's important that you do that extra practice. Your first quiz is on Thursday, 2 days. And it is over Basic Concepts Part 1, 2, and 3. So this is going to be on your quiz in 2 days, which is important then that you kind of get that straightened out because it'll all be mixed up on that quiz.